This video segment is a follow-up to the one that I just recently posted. The one that I did actually looked like so. Let me see now. Second. Right. Yeah, the one that I posted topologically is very similar to the one that I'm going to be doing now. It looked like this. So we had a part like so, and the left side of this part was clamped, and on the entire top face, there was a pressure that was acting on it, which made this thing bend, and it would eventually contact the bottom arm. And I've created contact condition, and also the type of element that I'm using is extruded or swept Breck elements. Okay. And I mentioned to you that there was no problem. This went very smoothly. However, when I tried to do the other problem, this one, although the process is the same, but there are some subtle issues that are going to pop up when it comes to sweeping this mesh, and I want to show you how to handle that. The other difference here is that the entire top face is not subjected to pressure, but there is a little patch on it that actually we have pressure applied on that. Okay, so what I'm going to do is actually I start with a pad. This is very easy to see, and I start with this and just proceed with the rest of the problem. The other thing is that here I have shown you the process that we're going to go through. We're going to extract the face to mesh it with shell element. On the top, we extract that top patch and sew it to the geometry to make a feature, and then we apply the load on it, and eventually we're going to solve the problem. Now, these are the dimensions. I mean, they don't have to be exactly the same, but if you are trying to recreate this, these are in millimeters. So some of these, of course, this is not completely constrained sketch, but by eyeballing it, we can decide what the angle should be, or perhaps what the length should be. Okay, so let's go ahead. Let's go to there. Okay, the first thing that we want to do is on that top face. I'm going to draw that rectangle because we want to make a patch up there, right? So we go here, and I believe, right. Okay, so we need to make the rectangle over there. Rectangle, something like that. I'm just based on what I saw in the figure. I'm roughly drawing it. So there is a this line, control that line. We make it coincident. Okay, very good. And this line, control that line. We also make it coincident. Okay. Exit. All right. Now we are in the generative shape design, and therefore I can put a surface through that. So we're going to fill right there. See that? Fill. This sketch, the sketch that I just created. Okay, and later on I'm going to sew it to the geometry below it. Now, the other thing we want to do is we want to extract this face because we want to put a shell mesh on it and eventually sweep it. Okay, so where is the extract? Extract is in the operations toolbar, the third set of icons, the middle one is right there, extract. So I'm going to extract this. Okay, very good. So we have a extracted face, and that patch that we created up there by filling it. Now we're going to go to generative. We'll go to part design, because in order to create a feature up there, we have to sew that fill into the object. So here's a sew surface-based feature. So this is the surface that we're going to be sewing. The direction of the arrow should be flipped, and Let's uncheck the simplified geometry. I don't usually leave it there, so there we are. Okay, good. So that's pretty much it. Let's save this thing. All right, now we're going to go to advanced meshing tools, because what we like to do is we want to create a shell mesh here. So let's go to advanced meshing tool. There we are. And I also want to remind you that I have customized my interface so that when I click on that, I get my favorite workbenches showing up. But if you're a newcomer, you go to mechanical, what is that? Analysis and simulation, advanced machine tools. Okay, very good. Now, let me change the rendering here. Okay, good. Now, surface measure is right here. There's the surface measure. This is meshing, I suspect it's meshing method. I'm not sure what the thing said, but the surface measure is right there. You select that face, the extracted face, and you give it the size of the element that you want. And since I want all quad elements, I clicked on this box instead of that one. That'll give you a combination of this one gives you actually triangular one. This one quad, and I want quads only. Okay. Now size 5mm. Let me see if in this uh, slide did I give you an indication of what the size of the element should be? No, we'll make it 5mm. If necessary, we're going to change it. Okay, you click on it. Now, when you click on it, it's not meshed yet. You have to click on this icon down here, which says mesh the part. You click on it, and if you're happy with this, and I am, you say OK, and you exit. You have to exit. There is the exit, the advanced, the surface measure. You have to exit the surface measure. It's right there. Okay. I don't think we need to do anything else. Oh yeah, we want to sweep this this surface mesh that we created in order to get break elements. See, sweep 3D, sweep 3D. You click on it, and this is where you may run into some problems. The previous tutorial it was okay, but this one I'm pretty sure they're going to run into some issues. And let's see now. First of all, the prompt says, okay, look at the bottom left corner. It says select the volume to mesh. Okay, the volume is this part. And then the bottom face means the face that you the bottom face means the face that you meshed with shell elements. It's right there, this one. And the top face, I don't know why they call it top and bottom, but anyway, the top face is the other side. Now, when I say apply, if there are no issues, this is going to get swept and the mesh will be created as it happened in the previous tutorial. Yeah, so you can see what the issue is here. It says captured bottom mesh failed. No mesh is captured on geometry vertex. Check capture mesh part filter and the capture tolerance. This means nothing. It took me quite a while to find out what the heck is this talking about. So when I looked at it carefully, I noticed that when you go close, you see this. These are guides, and there's 11 of them. Each one of these is a guide. When you look at this guide, you see that it doesn't start, this one doesn't start at the corner point or at the node, okay? This one does, this one does not, and this one does not. So what I need to do are there any other ones? Let's check the other ones. There are other guides that are having problems. This one seems to be okay. No, this one is not either. See that? So what I have to do, the other ones, I believe they're okay. What you need to do is exclude those guys. 4 of them, I think we went through them. 4 of them you have to exclude. Okay. So if you put the cursor here, it says exclude guides. Exclude guides. Okay. All right. It says, okay, go ahead and exclude the ones that you don't want. Well, one of them is for sure is this. Remember, it was not starting. It was not starting at the corner point at the node. Okay. One of them is this. I have a hard time picking it. Oh, come on. There. Okay, so far one edge. Where's the other one? The other one was over here. Now you may have a hell of a time picking these because there's some stuff sitting on top of that. For example, if you go to your part, there's some stuff sitting there. For example, let's see now. This so not so, but the fill, for example. Uh, Still sketch. See that? Sketch. Uh, okay, now we can pick it. I did not when I was doing this problem, I spent a lot of time trying to figure out why is it I can't pick it. And it turns out there are all these other things that are sitting in the screen on the screen, and obviously you need to select the guide and you have to hide them. Okay, here's another one. So far we have selected two. Here's another one. There. And there was another one on the other side. By the way, if you forget to pick all of the ones that you want, you can always go and fix it. But anyway, right there. There. I don't think the other ones were problematic. So yeah, so for example, if you look at this, these are all at the corner point. Okay. So you say okay, and hopefully now we can mesh it. How many layers, by the way? Let me go check number of layers. 8. I don't know what I had here, roughly what I had. Yeah, it looks like 8. Okay, fine. So apply and pray. There. I couldn't resist making this tutorial this video, because believe me, it'll take you a lot of time to figure it out. And the message that you got doesn't say anything. You try to fool around with these tolerances and nothing will happen. Okay? So we say, okay, good. Now, remember to deactivate this surface mesh. We're done with the surface mesh. We don't need it anymore. So you have to deactivate it, and you have to do that while you're in advanced machine tool. If you try to do it in a different workbench, so that generative structure analysis, etc., it won't let you do that. So you have to go back and activate it, deactivate it there. Deactivate right there. Deactivate, select it, right click, deactivate, and it's gone. Okay, good. Now, the next step is to apply 3D property on this, and then apply load and restraints and things like that, which is not a big deal. We're going to have to do that in generative structure analysis. There's a generative structure analysis. Okay. Now, what do we save on analysis file? So let me minimize these things. I don't need it. So file, save management, analysis is right here. Save as. There's already analysis 1 there in that folder, so let me call it 2. Something that I did earlier was sitting there. Okay, very good. By the way, the excluded guides, you can see that they're represented by this blue thingy, which is actually, if you look at it under the sweep, you see that it says these are the excluded guides. If you hide this, all those blue stuff on the screen are going to disappear too. Well, no, not there. Okay, close. Hide it. If you hide it, they're going to disappear. But I wanted to show. It doesn't matter. Oh, okay, excellent. So first of all, I don't need this extracted surface. I'm going to hide it. Then we have to do 3D property because we swept this mesh. It doesn't know what the properties of it is. You click on 3D property and you select the swept mesh, and it immediately picks the material, aluminum. You're almost done. So the left side is clamped. Okay. The right side on the top, we can pick this because we sold it. We created a feature and sold it. So now there's a feature. And what was the value of the pressure that I wanted? Well, let's put down 82,000. How about that? 82,000 kilopascal. Okay, then I'm going to change it. You'll see why. 82,000 kilopascal. On that face, okay, we did it. Good. We now have to create a connection, a contact connection between this face and that face because they can't penetrate. So we're going to do that with creating an analysis connection first. I've done many contact problems in this channel. So first you have to create a connection, analysis connection between this face, and for the second component, the bottom of that. Okay, this is the connection is created. And then we declare this connection that we just created as a contact. Right there, we created. There is the one that we created. See that? Lights up or highlights. Then we're going to do contact, face-to-face connection. The second one from the left, contact, and you select it either from the screen or from the tree, either one. So yeah, there's the contact. Don't worry about these unless you know the basics. Don't get involved with friction and stuff like that. I've done several tutorials where these are used, but right now we assume that there is no friction. Also, although there is, seems that there is a 0.3 here, but it's not checked. Okay, good, good. So that's pretty much it. So before running it, let me save and run it. Hopefully I didn't forget anything. That's okay. All right. So let's look at deflection. There we are. You can animate it. Okay. Now, obviously, if you put a bigger pressure, this is going to go even further down. So if I put down 10,000 kilopascal for ordinary aluminum, it's already beyond the yield stress. But let's run it again. There's going to be more deformation. That's all. Done. So let's look at the von Mises stress right there. Now, you might say, whoa, wait a minute. Why did these things penetrate each other? Because you are exaggerating the scale. See that this amplification factor, it says that you are making the displacements 5 times bigger, okay? So to see the true scale, let me make it scale of 1. And true scale, they should not be penetrating. If you make 5 times bigger, because the deflection of that top arm is so much more than the bottom arm, it gives you the illusion that this is actually penetrating. Well, it's not penetrating. To see that, you set the scale to 1, and you see that there's no penetration. Now, let me do a couple more things. I want to remind the user that it's entirely the responsibility of the user. If they're doing linear analysis and they put loads there which are too much, causing too much stress, too much deformation, Catia will not complain. If you're doing linear analysis, you put in a number, you're going to get a deflection. Okay? For example, if you put 10 billion kilopascal, well, you're going to get a deflection which may be 5 miles or 3 kilometers, whatever. Now, Catia will not complain, but you are the one who have to look at these numbers. Just getting the color does not mean you're doing it right. The other thing that I would like to do here is, if you want to see the stress distribution on the top face of the bottom arm or the bottom face of the top arm, what you can do is you can create groups. I did it in the other video segment too, the earlier one, but let's do it one more time. So we're going to create surface groups, not by neighborhood, surface group. Where is it? Surface group. This is point group, line group, surface group. And group 1 is going to be this. We can call it the bottom arm. How about that? Bottom arm. Sometimes maybe a good idea to give these things meaningful names. And then another one, top arm. And you go and select it, and it's going to be this curved surface. Okay, now we are ready to display the stress distribution on that. So you activate the one Misa stress. You don't have to run it because it's already there. Double click on the screen the contour, and just show me, for example, the uh, bottom arm there. Now that should not surprise you because the bottom arm is basically a cantilever beam. The biggest is bends, and the biggest stress is going to be at the one Misa stress is going to be at the support. The support is right here. Now, if you want to see the top arm, oops, not the top arm. Where's the other one? Ooh, oh yeah, this. Okay. The biggest stress for this problem happens to be in that area, and part of the reason is that I did not put any fillets here, and that's why you're getting gigantic stress in this area. So, well, that's all. The one problem that I have not done is what if you have an orphan mesh, and in other words, what if this mesh was not created in Catia but came from a different software? There's no geometry here when it comes to creating surfaces or contact. I don't think you can do that, or at least I don't know how to do it. Okay, good luck.